Unit 4.3 is theorems involving parallel lines. Theorems involving parallel lines. Theorem 4.8 says if three parallel lines divide one transversal into two equal pieces, then they will divide every transversal that passes through them into equal pieces also. So we have three parallel lines. When those three parallel lines are cut by this transversal, it divided that transversal into two equal pieces. So according to that theorem, it will divide every transversal that passes through there into equal pieces also. So if this little piece is 4, then the other little piece is 4. If three parallel lines divide one transversal into two equal pieces, then they will divide every transversal that passes through them into equal pieces also. If three parallel lines divide one transversal into two equal pieces, then they will divide every transversal that passes through them into equal pieces also, so x equals 5. Theorem 4.9. They get a little bit more complicated as we go here. If a segment hits the midpoint of one side of a triangle, the segment in question here is a M. If a segment hits the midpoint of one side of a triangle and is parallel to a second side, then the conclusion is that it must hit the midpoint of the third side. And so our conclusion is that M is the midpoint of segment CD, which would prove to us that segment CM is equal to segment DM. Okay? We were given the blue and the green, and we concluded the black. If a segment, the segment in question is AM, hits the midpoint of one side of a triangle, that's the blue, and is parallel to a second side, that's the green, then we reach the conclusion that it must hit the midpoint of the third side, that's the black. Okay? And then theorem 410, which is basically using the other two pieces of this situation to prove the parallel sides. It's kind of using the other two pieces to prove that. Theorem 410 says a segment that joins the midpoint of two sides of a triangle. The segment here in question is BD. It's given here that BD joins the midpoint of two sides. Given that that is true, that a segment joins the midpoint of two sides, we can reach two conclusions. Number one, it is parallel to the third side. And number two, its length is half the length of the third side. And so BD would be half of CE. So BD is half of CE, which would be 1/2 of 16, which is 8. Having concluded that this is parallel to the third side, we then can say that corresponding angles are equal. And so we can conclude there that angle 1 is equal to angle 2, you can see that they make the letter F because corresponding angles are equal. And angle 3 is equal to angle 4, they make an F the other way, upside down and backwards. They're corresponding. So since we can conclude the lines are parallel, then we can say that alternate interior angles are equal, corresponding angles are equal, same side interior angles are supplementary, and all of those properties of parallel lines. So in summary, if a line is parallel, if three parallel lines divide one transversal into two equal pieces, then they divide every transversal that passes through there into equal pieces also. If a segment hits the midpoint of one side of a triangle and is parallel to the second side, then we can reach the conclusion that it must hit the midpoint of the third side. And thirdly, a segment that joins the midpoint of two sides of a triangle has two properties. Number one, it is parallel to the third side. And number two, its length is equal to 1/2 the length of the third side. So we're going to go right into the daily work here also. We have way over here marked that these three are parallel. So we have three parallel lines. If three parallel lines divide one transversal into two equal pieces, then they will divide every transversal that passes through there into equal pieces also. And so DE is 5, EF is 5, so DF is 5 plus 5, which is 10, and you can do the work to find HI and JL. If three parallel lines divide one transversal into two equal pieces, then they will divide every transversal that passes through there into equal pieces also. Now this next little section is a little bit tricky for students. Got all kinds of marks and errors, and we're dealing with those theorems. So let's just look at number 4. Now number 5's in the odd answer, so you can find that one there. But here's what we have. We have that alternate interior angles are equal. See that? Now, if that's true, then that tells me that this side right here is parallel to this side because alternate interior angles are equal. And I know then that this is a midpoint. Now, we know that point D is a midpoint because those two are equal. What we're going to have to do is use the theorem that says if a segment hits the midpoint of one side of a triangle and is parallel to the third side, then it must hit the midpoint of the other side. Now, right now we're going to have segment BD in question. BD hits the midpoint of this side. It's parallel to the second side. Therefore, according to that theorem, it must also hit the midpoint of the third side, which proves to us that point B is a midpoint. And so now we know that B and D are midpoints. But then we think, well, what about F? So we got to kind of look at F. Well, we know that this is a midpoint. So let's look at segment FD and see if that'll prove it. FD hits the midpoint of one side. Do we know that FD is parallel to the second side? We have no way of proving that. If we can't prove that, then that theorem doesn't apply yet, so we're left to wonder if F is a midpoint. We cannot reach that conclusion. So the only two that we can conclude that are midpoints for sure are point D and point B. Okay? Now, you realize here you got a lot of alternate interior angle stuff going on. You've got something equal here. You've got some alternate interior angles going on. So there's a lot of stuff to think about as you try to apply all of that. And you're just going to have to try to work your way through it. You get stuck, call your instructor and ask them how to do it. Or find somebody in class that understands it. Again, number 5 is an odd one, and so you will see it explained in the odd answer portion of the textbook, which is at the end of the chapter. Now, on this next pair of problems, this pair of pictures, we're going to use what we know from those theorems to try to solve. Now, here we have in question this particular segment YQ. Now, it fits a theorem which says if a segment joins the midpoint of two sides of a triangle. A segment that joins the midpoint of two sides of a triangle has two properties. Number one, it is parallel to the third side, which we would show with arrows. And number two, its length is 1/2 the length of the third side. See how we got that equation? Its length is 1/2 the length of the third side. A segment joining the midpoint of two sides of a triangle is parallel to the third side, and its length is equal to 1/2 the length of the third side. Now, if it is parallel, then corresponding angles are equal, so that's 50 degrees, and corresponding angles are equal. And we also know that the sum of the angles of a triangle is 180 degrees. So you can finish out those angles and answer all of those questions. Let's deal with this situation. Sometimes students get scared with fractions. When you deal with fractions, you want to make them improper. So we're going to say 6 times 4 is 24 plus 3 is 27 of those little fours is equal to 1/2 XR. If we want to solve for XR, we're going to undo multiplication by division, or if you want the answer to that or question, look at page 25, example 3, especially 3A and 3B on page 25 of the Algebra 1 text. Algebra 1, page 25, example 3, 3A and 3B. It says we undo multiplication by division or multiply by the reciprocal. Multiply by the reciprocal. Now that makes those cancel, and we get XR equal 2 goes into 2 once, 2 goes into 4 twice. We get 27 over 2, which is acceptable. We could divide and get a mixed numeral, or we could get the decimal 13.5. Any questions on that? And we'll leave that next picture worth of problems to you. Again, we encourage you to use your protractor, do the measuring to get good at it, reach these conclusions. Again, if you are off just a little on your measure, then go ahead and tweak them till they're all correct according to the rule in the next lesson. And we will discover in this process the rules to the next lesson, which are going to be the special properties of special quadrilaterals of unit 4,4.